Good day, everyone. Today we are going to discuss uh, 2023 January season, second unit, second paper. Unit 2, Energetics, Group Chemistry, Halogenoalkanes, and Alcohols. Right. In this video, I'll discuss only the first question. Then I'll drop some videos to the only difficult questions. And question number 1. The student measures the enthalpy change of combustion of methanol CH3OH using the apparatus shown. There is a thermometer, a stirrer, and copper calorimeter containing 50 cubic centimeters. 50 cubic centimeters. After burning 0.20 grams of methanol, the temperature of the water increased by 16 centigrades. The measurement uncertainty in thermometer used in the experiment is 0.5 centigrades Celsius for each reading. Right. For each reading. Here I am going to underline the important points of the question, the details, uncertainty, and what is the percentage uncertainty in the temperature change. Temperature change. They are asking percentage uncertainty. When you read a thermometer, when you take a reading, there is a error. There is a like uncertain value, right? So that value is given 0.5 centigrade, and you have to take the temperature change. Temperature change, guys. Temperature change. Temperature change. Delta theta is equal to final temperature minus initial temperature. Final temperature minus initial temperature. And when you read the thermometer one time, there is 0.5 error, right? When you read it one time, 0.5 error, right? To take the temperature change, you have to read the thermometer twice, because it's final temperature. To take the final temperature, you will read it once. To take the initial temperature, you will read it another time. So 0.5. So when you read it twice, each time there is an error 0.5, there is an uncertain value of 0.5. So total error, total uncertainty is 0.5 Celsius. And temperature change, sorry, total error is 0.5 plus 0.5, 1 centigrade, right? The reading is 16. Percentage uncertainty. So answer should be 6.25. Round off it 6.3. Right? Answer should be C. Right? To take the temperature change, you will read the thermometer twice, and each time there is 0.5 Celsius error. When you take the temperature change, you will read it twice, then 0.5 times twice, 0.5 times 2. This much of total error, right? And reading is 16. Right, I hope it's clear. Question number 1, part B. The student repeats the experiment but burns 0.3 grams of methanol and uses 75 cubic centimeters of water in the copper calorimeter. What is the expected temperature change in this experiment? Right? Back to the apparatus. I'm going to raise the these details since we need more space to write some things. Part A answer is C. Right. Here, guys, first we have to understand the phenomenon clearly. Spirit burner, it uses methanol, methyl alcohol, right? It burns methyl alcohol and emit heat. It emit heat, and that heat is absorbed by the water, right? The spirit burner emit heat, and that thermal energy is absorbed by the water. Then heat or thermal energy emitted by the burner, spirit burner, is equal to absorbed energy by the water. Absorbed thermal energy by water, right? You have to understand this part first. Heat emitted by the Bunsen burner, sorry, not Bunsen, the spirit burner is equal to absorbed heat by the water, right? Okay, heat emitted, you have only the mass of the burn, mass of the methanol that burn. So let's assume it contains 1 joule of energy in 1 gram, right? Methanol, it contains 1 joule of energy in 1 gram. Then 0.2 grams means 0.2 times 1, 0.2 joules, right? 0.2 joules. Emitted heat by the Bunsen burner, 0.2 joules. Absorbed heat by the water, you need mass, but we have volume. Mass divided by volume equals density. Mass equals density times volume. Guys, density will cancel out in the calculation, but for the convenience, I am going to put it as D. Density of the water as D, right? Then for the mass, you can get uh, density D times volume 50, right? 50 D mass times absorbed heat mc theta, mass times the specific heat capacity of the water C, times temperature change is given 16, right? Equation 1. And I am going to make the C subject of the equation. C equals, specific heat capacity C equals 0.2 joules divided by 50 D times 16, right? I just write equation for the first part, right? And for the second part B, again heat emitted by the lamp is equal to absorbed heat by the water. So emitted heat this time 0.3 grams. So we have assumed that 1 joule contains 1 gram in 1 gram, so 0.3 joules. Emitted heat is 0.3 joules equals absorbed heat mc theta, mass 75 times density D, 75 D. C water, so C is constant, times temperature change, we don't know, so I am going to put it as theta. Again, make the C subject of the equation. C equals 0.3 divided by 75 times D, 75 D times theta. right? So here C, here also C, and guys, C equals C, and if this is third equation, 1 equals 3, not 1 actually, right? Somehow C of the first part equals to the later equation. 0.2 joules divided by 50D times 16 equals 0.3 divided by 75D times theta, right? D to D cancel out, and theta equals theta equals theta times 75 times 0.2 equals 50 times 16 times 0.3, 0.3. Theta equals 50 times, guys, do the calculations by yourself. I'm just giving you a help. 0.3 divided by 0.2 times 75, right? 25 times 2, 25 times 3, and 0.2. 0.3 times 1, 0.3 times 10, 0.2 times 1, 0.2 times 10. 10 to 10 also cancel out. Theta is 16. 16 centigrade. Theta should be, temperature change should be C, 16, right? Okay, guys, the emitted heat by the lamp, the emitted heat by the spirit burner is equal to absorbed heat. Let's assume that heat loss is zero, that emitted heat is absorbed by the water, right? So emitted heat by the lamp Q is equal to absorbed heat mc theta, right? You have to write one equation, first equation for the 0.2 grams and the temperature change 16, and 0.3 grams with 75 cubic centimeters, another equation, right? Right, I hope it's clear. I'm going to move to the third part of the first question, part C. The students calculated enthalpy change of combustion of methanol is more exothermic than a data book value. What is the possible reason for this? The students calculated enthalpy change. Okay, enthalpy change delta Hc of methanol is more exothermic than a data book value. What is a possible reason for this? Okay, let's read out the options. Heat loss to the surroundings. If there is a heat loss, that might be affect. It's possible, but let's read the other options. Incomplete combustion of methanol. Incomplete combustion of methanol. There is no reason to occur the incomplete combustion because methanol is very volatile, and usually in normal environmental condition there is like enough oxygen to burn methanol, like in fully combustion, and evaporation of methanol from the wick of the spirit burner it evaporates, but when there is a flame, that evaporated uh, particles, methanol particles, burn. So it would be like very smaller value, even though there is a excess evaporation of methanol. Use of molar mass of ethanol C2H5OH in the calculation. Now, this is a major mistake, right? Because in methanol CH3OH 12 3 plus 16 plus 1, 15 plus 17, molecular mass is 32. But if it is ethyl alcohol ethanol, 24 plus 5 plus 16 plus 1, right? 16, 46. So the molecular mass is very different, and that would directly affect to the values. Those are also mistakes, but you have to find out most suitable answer. Answer should be D. Right? It's not ethanol, it's methanol. It clearly mentioned in the first part. Methanol. See, CH3OH. Right. Uh, okay. So hope you this would be help for the help you to improve yourself. Okay. See you next time. Bye.